Hi there, and welcome to another episode of Draw, Make, and Code. I'm your host, Ed Cavett, and in this episode we're going to be looking at the textToPoints method to make some text art in p5.js. Here's the code. You can find links to this in the description. If you want to just play around with it, grab it, go for it, see you later. If you want to know how I put it together, and if you want to maybe want a run through of the different procedures and processes, then stick around and we'll go through each one of these lines and describe what's going on here. So in the global space of our sketch, we're going to declare a variable to hold the font. We want a variable that hold our object, which is going to be our particle systems. And then we need a variable to hold our messages that we're going to put into the particle system so that we can get different text each time we cycle through our animation. Before we do setup, we're going to preload our font, so we're just upload that into your resources here and then access that font. It's a true type font or an open typeface, open type font. Either of those are have the vector information that p5.js will use to get the points out of it. So set up your font there. Then in setup, we're going to use the available window width and window height. And before we instantiate our object, we need to set into the message array some messages. So right now it's blank. Let's set some messages in there. And that's how you do this. Just use a variable and push into it whatever text you want there. And you can use however many messages that you want, however many lines or whatever. There's really no end to it. Then we are going to instantiate a new object here, and this is the function that we're going to use. I call it line maker for whatever reason. I think when I started out with this, I was going to make an outline, and I just called it, instead of outline maker, it's just line maker. But you can call it whatever you want, just as long as you're consistent. And then you can change the stroke, how it's going to appear, whether it's got a round end or a square end or a projected end. It doesn't matter, that's up to you. Then in Draw, real easy, we're going to set some color to the background that contrasts with our output, and we're going to call or execute the method in our function liner. So here's a function here. We're going to instantiate, set up an initial state for our system here. So the very first thing we want to do is set the whatever message we're on in our list of messages. We're going to start with the very first message in that list. And then when we restart our system, we can move through different messages. We're going to find the points in the text that we're giving to the system, and then from those points we're going to figure out a target location on the canvas that's the shape of all those points, and then we're going to have some darts that we're going to throw at the target. So we need two arrays to hold that, one to hold our system of target location and one to hold the objects we're throwing at it. And then so that everything doesn't fly at it at the same time, we want to have a condition that says whether or not this point is moving or stationary. And we can set them all to stationary to begin with, and then we can flip each one on in sequence and set it flying toward the target. So we need an array to do that. Also, we need to tell it how fast we want these particles to move toward the target. So we need an array so that each particle has its unique velocity. You can set the velocity for each particle the same. Matter of fact, let's do that real quick. You can see there's a variable at the very end. It has three arguments in the parameters. One is for the dart, the other's for the target, and then one for how fast. So we can set this equal to a number between 1 and 0. So I'm going to use 0.25, and let's do the same thing for the y. So we have the x coordinate and the y coordinate represented there. Now every particle has the same speed. We see the output when every particle has a unique velocity. They spray out, but let's look at it when they're all the same. You can see now it kind of snakes out like a rope. Two distinctly different outputs from just a change in these conditions here. So let me set those back. Now I don't know if you prefer how it ropes out like that or if you like it spraying out. Either way, it's easy enough to change, so you might even have a condition in there that will change the style depending. Whenever it restarts the system, it picks a different style, whether it comes out at the bottom or randomly around the screen, whether it's sprayed out or comes out in a rope. Those can all be stochastically determined. So let's set it back to the way it was. Here it is. They're spraying out in different pieces at different velocities. I like how it's kind of scrambled as it moves into position, and that gets more organized. I kind of like that, but whatever you prefer. So let's go back up here to our initial states, now that you know what this variable is doing. What's this one doing? Well, when we set here's the statement. Let me start with this. This is the statement in p5.js that's actually going to assign to a variable the array of locations that describes this text that we're giving to it. So here's the keyword here. We're using the font that we've uploaded into our resources. That's what it's going to access to get the vector coordinates. Then we put our message in there, and then we have some arguments here that describe some details. This is the location of where the particles, where this array is starting at. By default, it starts at 0, 0, which is a fair enough origin. It's easy enough to work with, so I'm not going to change that. Then there's the text size, which we're going to set that to 10, because that's like the standard. And I think it's small enough that if we just printed it out that size, all the dots would be practically next to one another. So how many samples of those vectors are we going to take? Are we going to do all of them, or are we going to go so far and pick one, go so far, pick another? So that's determined with this value here. And then there is a way to simplify points. So if we have like a line of points, we can omit all the points between those two and just have from, like, say, one corner to the other, there might be 6 points representing that line. We can get rid of all those points in between and just have the beginning and end of that sideline or whatever. So that's what this does here. You read the documentation, I'm sure it explains it a lot better than I just did, but that's the breakdown of what you're getting. So once it figures out, it does the analysis on your text, it's going to set to this variable here. Now you don't have to declare this as an array. When you perform this operation, p5.js is going to look at this variable, it's going to say this needs to be a blank array, let's blank it, and let's put into that array the array of points that comes from textToPoints. It's kind of doing that for you. But when it does do it, it's going to return, it's going to make this an array of points. And we're just going to let that be its own thing for now. It's a normalized value because we've set that right here. If I wanted to, or could, I could multiply this times this dot size, and it would give us the magnitude of points that we're looking for as output, because right now they're too small. We need to expand those points. We could do that here, or we can do it down here in another operation, which I'm going to do it down here in another operation. So that's basically what's going on with this dot size. It's basically multiplying, or it's a magnitude of the normalized size that we get whenever we first pull the array out of the text. Then we want to release these particles in sequence one at a time, and so they don't all fly there at the same time. That's cool if you want to do it that way. That's kind of a neat effect, but I kind of like how it's spread out over time. So to do that, we want to count through each point and release those in sequence. So how do we restart the system? When do we know when to restart the system? Well, if we restart the system whenever we let go of the last point, we're not going to see the last character completed. It's going to be in process whenever it restarts. So what we want to do is keep track of how close the last particle is to its target, and when it gets really close, then we'll restart. And that's how we know everything is put together and is where it needs to be before we reset the system. So to do that, you set your threshold for that closeness right here. Next thing we want to do is an easy variable. We're going to set our message, our text, as determined by this element in the array. We're going to set that equal to m. And then we're going to use that easy variable inside the parameters, the text argument there. And then that's the syntax for the actual statement that does the extraction of points from our text that we've given it. The next thing we need to do is figure out where are we going to start this text at on the canvas. We need to know how big the text is, and not the normalized text, but the actual sized text. So to do that, I thought, let's just loop through all of the particles in the system and keep track of the rightmost particle. So that's what happens here. We're going to set center text equal to 0. We're going to assume that the rightmost particle is the leftmost particle to start. And then we're going to loop through all the particles. And we're going to look at the anchor value. So this is where we're going to expand things, because now we want to look at it as it's going to be as output. So to do that, we're going to take our normalized value, multiply that times the size that we've determined in our instantiation, and we're going to do that for x and y, and that's just going to expand that text and make it larger. And once we have those actual expanded coordinates, now we can see what width this output is. So then we have a condition here that looks at the center text, so it's 0 to begin with. It's going to look at that, and now it's going to look at the x position of the current particle. Am I less than that x position? If I am, then I want to be that x position. It's just going to keep doing that until it gets all the way to the rightmost particle. And once it's the rightmost particle, now we know the overall width of the output. And then once we have that, we can figure out where are we going to start this output on the canvas to get it centered. So that's what's happening there. While we're inside that loop, we may as well set the moving state, this boolean that decides whether they're stationary or moving. Let's set that to 0 so that everything is stationary to begin with. Outside of the loop, let's figure out an easy variable for the center position. And to find that, we're going to go to the center of the width, so width divided by 2, and we're going to subtract from that half the width of our output. So that's that center text value, that's that maximum width, 0 to whatever center text figured out to be. Divide that by 2 and then subtract that from half of the canvas width, and that's going to give us our starting position. And then when we output, it's going to start where it needs to be, it's going to go over the center and end where it needs to be. Let's stop this. Okay, so the next thing we need to do is figure out where our darts are and where our target is. And I could use the this.anchor array as our target and just forget the target array altogether. But if I want the targets to move around some, if I want those to change, maybe I want them to evaporate and float up to the screen or fly away at some point and then maybe revert back to where they need to be, then I need to have a reference for that. So I'm using this.anchor as a reference set that will always have the clean, perfect layout of my coordinates. And then I have target, which I can leave the same if I want, or I can change them and then revert back. I have that as an option. So that's the reason why I'm using these two different sets here. That being said, let's create a loop and let's go through all the particles in our return from the textToPoints. So this array here, this anchor. So we're going to look at that and we're going to set an easy variable, set x, to the adjustment. So right now the rightmost position is 0 and the leftmost position is whatever width this output is. So I need to move that over so far. So I'm going to add that to that calculation that I made up here, center. So now instead of being on the left-hand side of the canvas, it's going to get pushed over a little bit so that it's centered. And that's what this does right here, or this does right here. And then for y, let's just move down half the screen. So the height of this output isn't so much that it needs to be perfectly centered. It can actually start at halfway down the canvas and be above it a little bit or below, it doesn't matter. So I'm not going to make the adjustment to the y. So it's fine if you just add half the height to get it centered roughly in the center of the canvas along the horizontal, the vertical axis. So once we have our easy variables set, we can use those inside the create vector method, and we can push that inside the target elements. So we're going to use this.target and push and create vector, and we're going to put set x and set y, and that's going to create our target points where they need to be. And that's perfectly matching our reference, which is the output from textToPoints. Dart's a little bit different. We want those to travel toward the target, so they need to be away from it to begin with. And you can put them randomly away all over the screen, and then they just fly randomly toward it. Or you could position them at the bottom in the center like I have here and have them fly, or you can situate them so they run in sequence from the left part of the bottom to the right, or maybe they go all the way around the screen, or whatever it is. You can get really elaborate with the placement, the initial placement of these particles. You could have them be placed as one word, like a different set of words, and then when they fly toward the other target, they change into a different set of words. So just use your imagination, but for now this is all they're doing here. It's just flying from the bottom at the center. And they're moving so fast. So you can see here the lerp velocity, and then there's a random number put in here. So when these particles are traveling when the darts are moving toward the target, they're moving through the lerp method. So let me find that down here in the code. Did I just go way too far? Right here. So here's how they're moving. Each dart is moving through linear interpolation. So I start with the dart's position, move toward the target's position by this much each cycle interpolated. So right now each particle has its own unique velocity, but if we change those, then it will travel did I do this? I've recorded this so many times I can't remember if I've shown this in this version or not, so let's do it again and maybe I'll cut it out if I have already. So now we're into this.update. The very first part of this method is we want to move to the next dart and let it loose so it can go flying toward the target. So that's what this is going to do. Then to make things easier, let's set a local variable equal to however many particles are in the system, -1. So now we're at the method this.update. And the very first thing we want to do is set loose the next particle in sequence. So if we're on the very first dart, we're letting it go. And that's what this does here. This is keeping track of each dart in sequence. Then we're going to set an easy variable equal to the very last particle in that system, the very last dart. And then we're going to look at the distance between the last dart and its target location. Once we've done that, we can look at the count and see if we're at the end. So have we let loose all the particles? If we have, then how close is the last dart to the target? And if it's really close, then let's restart things. And that's what happens here. We're going to set the count equal to last, which really doesn't matter because it's going to get reset right here. So this can be 0. I'm not even sure why this is here. Honestly, it doesn't need to be. I'm not going to take it out for now because I don't want to worry about it messing something up and having to spend time trying to figure out, but I don't think that's necessary. So then we jump to the restart method, which is down here. And I'll go over that real quick since we're at that point. So we've made it to the end. The last dart has landed. Now let's reset everything. To do that, we want to take all of our arrays and set those to blank. If we don't do this, then we're just going to be pushing the new points to the end of the array instead of starting over at the beginning. So that's what this is going to do. It's going to set all those arrays back to the beginning, so then when we start pushing elements in there, they're going to start at the beginning and move their way through the end, right? Then we're going to start over at the very first particle in sequence, the very first dart, so that we can let go of the first one all the way to the end. Here is where it's a little bit different. We're going to advance to the next message. So in the very first, when we instantiated the function, this dot message switch was set equal to 0. If you're just copying the instantiation part over to do restart, which is what I did, then just change that from it equals 0 to plus equals 1. And then put a condition that tests to make sure that it's never past the number of messages we have available, and if it is, set it back equal to 0. And then you can use an easy variable to find out which text message you're on, and then you can send that into the method that will find the array of points for it. And then we're doing the same things over again, so you can see here. So basically you're copying, let's go back up here to the very top of this function. You're basically copying all of this all the way down to draw. So if you go all the way down to you're copying it all the way down to update, the update function. So pretty much everything up in here, copying that over, and then you're changing this to plus equals 1 and adding the condition to make sure it stays in bounds. So that's pretty much all you're changing that to. So where were we at in this? Okay, we were done with this .update, weren't we? Oh yeah, we were at the restart. Okay, so we're out of this condition now. So we've made it to the end, we've restarted, or we haven't restarted, we haven't made it to the end. So we're following through and continuing with the process. And that process is turning on the dart that's currently being activated by the incrementer, this .count. So that's what we're doing right here. We're setting this as 0, now it's 1. The next thing we want to do is loop through the particles and animate them. And I found the best way to do that is to take all of the animation stuff and just throw it into its own method, which I did, called throw. No coincidence there. So these are basically the dart is being thrown. So how we do that is we loop through all the particles in the system, all the darts, and we set some easy variables equal to the target location for the x and y, and then we put those into the parameters of this method. And we also tell it which particle we're on. So if we go to that method here, we can see which particle we're on, the target's x and target's y location. And to make things easy, let's set dx for the dart's x equal to it, and the dart's y, and then the target's x and target's y. And then we want to find the distance between the dart and the target, so we're going to use that method right there. Okay, so the next thing we do is read what this says, so I know what this does. This is about the third time I've tried to do this. We have a condition. If we're so far away, then let's move toward the target, so long as that dart is activated and set to move. So we have kind of this double condition here. Is it moving? If it is it so far away from the target? If it is, you know. Then in the linear interpolation for the dart's x position, we're going to move toward the target. So use your dart variable there, your target variable here, and then give it its unique velocity. And the x and y have the same unique velocity. Once we've fallen out of that, we're going to use push and pop to isolate changes to the graphics attributes. And then we're going to do a condition that tests to make sure that we're not on the very first dart. If we are on the first dart, we're just going to skip over this. If we're on any other dart but the first one, now we can draw a line from our current dart to our previous dart. And that's where we get the outline for our text. So inside this condition, we want to set to an easy variable, a local variable, the distance between darts. And this is important because there's no distinction in the letters as far as the array is concerned when you're drawing lines between them. So the N will get joined to the E, will get joined to the O. Every particle is joined, whether it's a part of a letter or not. So you kind of have to keep track. If there's a wide enough distance between the darts, I can assume that I've left one letter and have moved to the next letter, because that's going to create a really wide line. So if I keep track of the length of that line, then I can kind of limit it and say, if the line is so small, then it's probably in the same letter, so let's draw the line. So that's kind of what's happening here. We're looking at the distance between the current dart and the previous dart, and if it's less than the size of the magnitude of our text. So the reason why I do this is because you may change the size of your text, and if you have a constant here that's not factored, then it's going to throw things off. So just use this dot size and multiply it times something to get your minimum threshold of distance, and then draw a line if it's below that. So that's what's happening here. So I have a default color here of black and a default width, and that's kind of like the starting state. And then when I reach a certain point, then it can start to glow with the blue, and that's what's happening here. I'm looking at all the darts. I'm going down that array of darts so far, like 75% of the way, and I'm looking at that dart and waiting for it to be let go or turned on. So I'm looking at this dot mover, the element number 75 out of 100, we'll say, and if it's on, then I want to activate this alternate animation. So you notice that as the output is being laid out, once it gets about 75% of the way, then it starts to activate the blue, flickering. So it's like the neon is being turned on. And that's how this is controlled here. And that could be halfway through, or 25% of the way through, you know, whatever you want it to be. I just have it 75% of the way through. Then in this condition here, I'm using some noise as like a noisy coin flip to flicker the neon output. So that's how the blue gets, it's turned on, but it looks kind of connected but not connected, and the disconnections keep moving through the text. That's done with this noise coin flip. So if everything's cool, we're going to draw the line after that. So the line is going to be drawn either way, but it's going to have this characteristic or it's going to have this characteristic here. And then outside of that loop, if the distance between is so great, then we're going to draw a point, and that's the little dots that are flying away. And that's just something extra. You can take that out or change it, put whatever you want in there, but that's just a procedure to let you know how to access the characters or the points as they're flying toward the target. So then you close that with pop, and then we can close that method. And I think that is it. That's the end of that. So that pretty much explains all of this code. It doesn't explain a lot of the stuff that you can do with it, though. I'll show you a few examples here. If you give me a second, I'll load those for you. So here is an example that has pretty much the same procedures. There's some extra stuff that's thrown in here or there to create a little bit of different output. And I don't know if you can see that long line in the A. That's what I'm talking about when you keep track of the distances between the current and previous point. And if it's so long between it, then you don't want to include that line. Here's another one that's kind of themed to what the output might resemble. Now if I had this as orange and red, it could be fire easily. So you can get to playing around with the characteristics of the output in terms of its movement, its style, along with its color. Work with those and kind of synergize those things so you can maximize the impression that this output gives. Alright, I think that's it for this episode. Thank you so much for joining me. I really appreciate it. If you like this episode, hit the thumbs up. You know, do all the stuff, please. Let the algorithm know that this isn't fruit that needs to die on the vine, that it's something that deserves being shared, because there's people out there that could really learn from this and want to learn from it and find it really valuable. So if they know it's there, that's going to help. So do all that stuff, please. And if you have been, thank you so much for that. I really appreciate it. And I guess until next time, as always, take care.